Gas metal arc welding. Gas metal arc welding, often called MIG, revolutionized arc welding. This process consumes electron in the form of the wire is fed with the spool through the torch welding gun at a preset control speed. As the wire passes through the contact tube of the gun, picks up the welding current consumed with the wire electrode, serves the two functions, maintaining the arc, provides filler metal to the joint. Method of delivery of the filler metal allows gas metal arc welding. Basically, one-hand operation, which does require the same degree of skill. Does not require the same degree of skill as gas metal arc welding. Show the basic principle of gas metal arc welding. Important factor of gas metal arc welding process with a high rate which the metal is beat apart with a high rate of the metal disposition, high speed of the welding results minimum distortion, narrow heat of the affected zone when deciding whether the gas tungsten arc welding gas MIG arc welding thickness of the material should be decided factor. MIG is often used the welding thicker metal of the gas tungsten arc welding or TIG. Gas metal arc welding also uses shield the gas to protect welding zone during the welding, and an air gas fed through the gun into the weld zone prevents atmospheric contamination. MIG offers many advantages over the TIG. Since there's no flux, MIGs are clean, therefore no slag to remove. MIGs enables you to produce sound welds positioned quickly. Now lets you make a look at the equipment you can use with the gas MIG arc welding. Gas MIG arc welding equipment and supplies. Gas MIG arc welding equipment basically consists of 4 mains: power supply, wire feeding machine, welding gun, and or as referred to as the torch, and the gas supply shown in the gas metal arc welding outfit. Welding machine. You use the conventional type of the welding machine, gas metal arc welding voltage depending on the length of the arc. Whenever the nozzles work, the distance change, the arc length, voltage change. The only way to produce uniform welds in this type of power source is to maintain arc and voltage at the constant value. Besides producing uniform weld line, inconsistent voltage can cause the wire to burn back a nozzle. A constant voltage power source developed to overcome inconsistent voltage characteristics of the conventional welding machine. It can either be DC rectifier motor generator, certain supply current, normally 200 to 250 amperes. The cold and constant voltage type power source has nearly flat volt ampere characteristics, meaning the machine has maintained same voltage regardless of the amount of the current used. The type of the power source you can change with the wire feed speed with a considerable range without causing the wire to burn back into the nozzle. When the wire feed speed is set at a specific rate, a proportional amount of the current is automatically drawn. In other words, the current selection is based on the wire feed speed. When the wire is fed fast, if the current increases. When the feed is slower, the current decreases. When the type of the power supply variations and nozzle work distance will not change, the arc of the length of the burn back is virtually eliminated. 825 shows the constant voltage power unit. In gas metal arc welding, direct current reverse polarity is recommended. You should recall from the previous section the direct current reverse polarity produces excellent cleaning action, allows for deeper penetration. Wire feed driver motor. Wire feed driver motor is used automatically to drive electrode wire to the wire spool through the gun up to the arc point. Vary the speed over the wire feed, adjusting the control of the wire feed control panel. Wire feed can be mounted on the power unit and can be separated with the welding machine. The welding gun function and welding gun to carry the electrode wire welding current and shield the gas to the arc area of the gun. It has the trigger switch, controls the wire feed, arc welds, weld the shielding gas welding operator directs the arc and control the weld. The welding gun MIG weld guns are available to many different styles, and some of which are shown in figure 826. These guns of the wire fed torch are automatic wire feeding machines pushes the wire through the flexible tube with the arc point. Alright, 826 show the gas metal arc welding guns. Figure 827 shows another type of MIG welding. Steelworkers could use the model, incorporate the driver motor with a small spool of the wire inside of the gun. Type of the gun is attached directly to the welding unit. Gas supply eliminates the need for the shepherd control unit wire driver assembly. As the gas tungsten arc welding torch, the torch nozzle must keep kept clean at all times. Also, you should clean the tube through the electrode wire passes each time the electrode reel is changed. Gas metal arc welding torch, wire fed motor spool, wire spade, and spool inside. Shielding gas. In gas metal arc welding with the tungsten arc welding shield, the gas have a major effect with the properties of base metal. Some of the shielding gas commonly with MIG process pure argon, argon helium, argon oxygen, argon carbon dioxide. For table 8-4 selection of shield gas recommended with the various both and with the MIG intake welding and process. Smoothness of the operation, weld appearance, weld quality, welding speeds are effective in different ways with each type of the metal with the thickness of the gas mixture. Argon. Early in the chapter we said that argon provides greater cleaning action than other gases because of the heavier than air. Argon blankets the weld and contamination. When using argon as a shielding gas, welding arc tends to be more stable for the reason argon is often used in combination with Other gases, arc shielding. Argon reduces spatter with the producing quiet arc, reducing arc voltage, resolve with lower power in the arc. Lower penetration combination, lower penetration, reduced spatter mix. Argon desirable to one welding sheet metal. The pure argon is seldom used with the arc shielding, except the welding such metals are aluminum, copper, nickel, titanium. The use of the pure argon to weld steel usually result undercoating pore bead. The contour penetration is somewhat shallow. Argon oxygen, small amount of oxygen added to the argon produce the excellent result of the normal oxygen added amount with a 1, 2, or 5%. When oxygen is added to the argon, improve the penetration pattern, then improve the bead, the contour, eliminate the undercut of the edge of the weld. Using argon oxygen, make sure that welding alloy steel, carbon steels, and stainless steels. Helium. Helium, like argon, inert gas, may be the few cylinders between two gases. Argon is heavier than the air. Helium is lighter than air. Helium high voltage change. The arc length changes whenever the helium and the MIG welding. More arc energy is lost in the arc itself. It's not transmitted to the working tungsten TIG welding. We said that helium produces a good penetration, fast welding speeds. For MIG welding, opposite is true of the MIG welding. Welding helium produces a broader weld bead but a shallower penetration. Because of the high cost, helium is primarily used in special welding tasks, welding non-ferrous metals such as aluminum, magnesium, copper, and use the combination of the gases. Carbon dioxide, argon, helium gases composed of a single atom of carbon dioxide. On the other hand, consist of molecules. Each molecule contains one carbon atom, two oxygen atoms at normal temperature. Carbon dioxide is essential for the inert gas. However, the high temperatures composed of the carbon monoxide and oxygen because of the effects of the oxygen atoms combined with the carbon and iron with welded metal wires. The gas must be contain deoxidizing elements. Deoxidizing element has greater affinity with the oxygen, readily combines with it, and some of the more common deoxidizers are lithium wire, electrode, magnesium, silicone, alloy, aluminum. Carbon dioxide used primarily with the MIG welding with a mild seal because of the low cost. The carbon dioxide is often used with a combination of the other shield gas for the welding different types of metal. Different direct current reverses direct current for reverse polarity. Generally, used with the carbon dioxide current setting 25% higher than the carbon dioxide when the other shielding gas. Carbon dioxide produces a broader, deep penetration pattern, produces the good bead contour. This is non-tendency toward undercutting. The only problem with the carbon dioxide gas tends to be arc violent. This can lead to the spatter problems. However, the most of the applications not a problem. Advantage of the carbon dioxide for outweigh the disadvantages. Regulator, you should use the same type of regulator flow meter with the gas mount arc welder that using the tungsten arc welder. Gas flows rate will vary depending on the type of thickness of the material, the joint design time necessary to connection two or more gas cylinders, manifold together to maintain a higher gas flow. For most welding conditions, gas flow rate is approximately 35 cubic feet per hour. The flow rate may decrease depending on the particular welding application. Final adjustment usually are made in the trial air base if the proper amount of the gas shield results. Rapid cracking, sizzling, or arc sound. Inadequate gas shielding produces a popping arc sound result of welded discolorization, poor spatter. Filler wires. The composition of filler wire used the MIG welding match to the base metal with the filled mild steel. You select the mild steel wire. Aluminum, you should select an aluminum wire. Additionally, you should try to select electrode wire that matches the composition of various metals of the welding. For instance, you can arc weld your welding type 308 aluminum. You should use the AR 308L filler wire. Wires are available in spool of the different size with various diameter of the 20,000th of an inch to 1/8 of an inch. You should select with the proper diameter of the wire based on the thickness of the metal with the welding as well with the position in which your welding wires use 20,000 inch, 30,000 inch, and 35,000 inch are generally used for welding thin materials. Use them for welding low, medium carbon steel, low alloy, high strength steel. Medium thickness of the metals are normally welded with 45,000 to 160 with an inch diameter. For higher metals, large diameter electrodes may be required. As you learned earlier, the position of the welding factors must be considered. For instance, when you are welding vertical overhead, you normally use smaller diameter electrodes. Special attention must be given to ensure that the wire is clean. Unsound weld, the result of the use of the wire with contaminated oil, grease, dust, and shop fumes. Can obtain the best welding result from the wire that has been taken out with a carton. When your wire should be stored in a hot locker, warm, dry area should be kept covered. If the welding is stopped a long period of time, you should remove the wire and place it in the original carton to prevent contamination. Wire stick out. Gas metal arc welding, where wires stick out, refers the distance for the wire extend from the nozzle of the gun incorrect to the amount where the wire stick out is important because of the influence of the welding current of the power source. This is the power source self-regulating current output will automatically decrease if the wire stick out. When the increases, conversely stick out decreases. Power sources force and furnish more current. Too little stick out cause the wire fused to the nozzle tip, which decreases the tip life. MIG welding wire stick out should branch for 3/8 of an inch, 3/4 of an inch. Smaller micro wire stick out should be between 1/4 inch and 3/8 of an inch. Wire feed speed, we stated earlier, you can adjust the wire feed drive motor to a wire speed adjusting is limited with a defined range depending on the wire current used. Wire feed speed measured in inches per minute with a specified amperage setting at a higher wire fed speed resolve with a shorter arc, whereas low speed produces a long arc and higher speeds for the overhead welding, flat position welding. Personal protective equipment, as with many of the welding process, safety is extremely important. Welding like a hood like used one unit shield metal arc welding should be used for gas metal arc welding. Correct shaded lens depending on the intensity of the arc. Chapter 3 provides a chart recommended lens shades based on the current settings of the machine. Eye fatigue indicates that you should use a different shade of lens. There is leakage around with a protective filter or glass. In addition, the welding hood, protective clothing such as gloves, apron, and should be worn bare skin. Should never be exposed to the rays of the welding arc because it could result in painful burns. Alright, types of gas metal arc welding. When using gas MIG welding process, the metal is transferred through one of three methods: spray transfer, globular transfer, and short circuit transfer. Each type of the metal transfer depending on arc voltage, current setting, electrical wire side shielding gas. Spray arc welding transfer high current range produces the rapid position welding metal. With the type of the transfer effect of the welding heavy gauge metal because it produces deep welding penetration. The use of the argon mixture of the argon and oxygen necessary for the spray transfer of the argon produces pinching effect with the molten tip of the electrode, permitting only small drop of the form transfer during the welding process. Spray transfer is useful for the welding aluminum, however it is not practical welding light gauge metal. Global transfer curve of the welding current low, but because of the low current only the few drops transfer per second. When the many small drops are transferred, the higher current setting the types. Transfer ball type, tip of the electrode grow in size before it's transferred the workpiece. Globe tends to reconnect the electrode workpiece, causing the arc to go out periodically. Results in poor arc stability, poor penetration, excessive spatter. Global transfer not effective with the MIG welding when used, generally restricted in thin materials when low heat is desired. Short circuit arc transfer, known as short arc. Short arc developed to eliminate distortion and burn through the spatter with the welding in a thin gauge. It can be used with the welding in all positioning, especially vertical overhead with the puddle control, more difficult in most cases. Used with a current below 200 amperes, wire of 45,000 of an inch, and the less diameter, smaller wire produce weld puddles that are small, easily manageable. Shielding gas metal short arc welding is 75% carbon dioxide, 25% argon. Carbon dioxide provides increased heat with the higher speeds, while the argon controls the spatter. Starting CO2 is now being used in short arc welding, however it does not produce an excellent bead contour the argon mixture does. Gas metal arc welding preparation key producing quality meldments. Gas metal arc welding process is in the TIG welding equipment expensive, therefore you should make every effort to follow the manufacturer instruction when preparing a MIG welding equipment. Joints, for the most part, same joint design recommendation other than the arc welding process. But even the gas metal arc welding, there are some minor modifications should be considered due to major welding characteristics. The gas metal arc welding process of the arc, the MIG of the welding is good, more penetration there over the arc size shield metal arc welding. Groove joints can have smaller root face than root opening sides. Nozzle does not have to be placed without groove, the less beveling on the plate is required. Gas metal arc welding actually lower material costs since they use the less welded metal in the joint. Equipment the following suggestion in general can be applied with the gas welding operation. Check all of the cable connections, make sure they're in good condition, properly connected. Check to see the nozzle is clean and the correct side of the particular wire diameter is used. Make sure the guide tube is clean and that where it's properly threaded through the gun. Determine the correct wire feed speed, the depth of the feed control, or accordingly. During welding, wire speed rate may have to be varied and corrected. Little too much height input. Make sure of the weld shielding gas, water coolant, and sources of the on, and adjust it properly. Check with the wire stuck out. Gas MIG welding process. With any other type of MIG welding process is contained with certain variables that must be understood. Follow many of the variables already being discussed. Section applies some of the varies of the actual welding process. Starting the arc. Good arc starting electrode must be in electrical contact working. The best result should clean the metal and impurities. Wires stick out must be correct because of the wires stick out. Increasing the arc initiation between becomes increased difficulty. When preparing a starting arc, hold the torch at an angle 50 to 20 degrees. Support the wave of the welding cable gas hose across with your shoulder. Ensure the free movement of the welding torch. Hold the torch closed, not touching the workpiece. Lower the helmet and squeeze with the torch trigger. Squeeze the trigger to start the flow of the shield gas. Energize the welding circuit. Wire fed the motor does not re-energize until the wire electrode comes in contact with the work. Move the torch toward the work, touching the wire electrode of the work with a sideways scratching motion shown in figure 829 prevents sticking. You should pull the torch back quickly 1/2 an inch of the instant contact is made between the wire electrode workpiece. The arc strikes as is contact made with the wire feed. Motor feeds the wire automatically as long as the trigger is held. So 829 shows the striking the arc. You show the torch in the direction of the weld. Properly established arc is soft and sizzling sound with adjusting wire feed control dial with the welding machine is necessary for the arc does not sound right. For example, the loading crackling sound indicates the arc is too short of the wire feed speed. It is too fast. May correct the problem by moving the wire feed dial slightly counterclockwise to improve the wire feed. Wire fed speed increase the arc length and clockwise move with the dial opposite of the effect of the experiment that you recognize the sound of the proper length of the arc to use. Break the arc, you may simply release the trigger to brake for the welding circuit. The energize of the wire-fed motor should wire electrode stick out of the work. When striking the arc and during the welding, release the trigger and clipping of the wire on a pair of side cutters. Welding position. Gas metal arc welding, proper position welding torch weldment is important with the position of the torch in relation to the plate of the work travel angle. Work travel angle shown in figure 830 of the parts of the equal thickness. The work angle should normally be on the center line of the joint, have a piece of the unequal thickness. Torch should angle toward the thicker piece. The travel angle refers to the angle in which the welding takes place. The angle should be between 5 and 25 degrees. Travel angle will be either push angle or the drag angle depending on the position of the torch. Alright, shows the fillet welds, travel angle, work angle, travel angle, front view, groove weld, and work angle, end view. Alright, shows pulling, pushing, travel angles, drag angle, pulling, pushing angle. When torching a head is welded, it is known as pulling weld. When the torch is behind the weld, it is referred to as pushing the metal. Pulling or drag techniques, heavier gauge utility draw techniques, and then procedure greater than penetration pushing techniques. Also saying that the welder can use the welder crater more easily, better quality with the consistently made pushing technique is normally used with the lighter gauge metals, Welds made technique less penetration wider because of the welding speed is faster. For the best results, you should position the weld metal in fat position, improve the molten metal flow with the bead contour to give it the better shielding gas protection. After you've learned to weld in flat position, you should be able to acquire skilled knowledge to weld out of the position. The position include the horizontal, vertical down, overhead positions. Only difference in welding out of position is flat position 10% reduction in amperage. Welding heavier thickness of the metal with the gas metal arc welding, you should use the multi-pass technique with accomplished overlaying, being single small beads of the making larger beads. The weave of the technique various multi-pass welding sequences shown figure 832. Number refers to sequence which make the passes common welded defects. Once you get the feeling of the weld, the gas metal arc welding equipment probably find the techniques less difficult to master many of the other welding processes. However, as with any other welding process, gas metal arc welding does have some pitfalls. To produce good quality welds, you must learn to recognize or correct possible welding defects. Following the few of the more common defects, go along with the corrective actions you can take. Alright, it shows the corner flat 1, 2, and 3 beads, horizontal V 1, 2, and 3, and 4 groove lap 1, 2, and 3. Overhead 1, 2, 3, 4, 5, 6, T flat 1, 2, 3. V groove 1, 2, 3, vertical up fillet 1, 2, 3, 4, 5, 6, 7, 8. Alright, surface porosity, usually the result of the atmospheric contamination could be caused with a clogged nozzle, shielding gas, too high welding winding area. Avoid surface porosity, should keep the nozzle clean, use the correct gas pressure, use protective windshield with the welding and windy area. Crater porosity, use the result of the pulling the torch and gas away before the crater has solidified. To correct the problem, you should reduce the travel speed at the end of the joint. You may also try to reduce tip of the work distance. A cold lap often results of the arc does not melt the base metal sufficiently. Cold laps often the molten puddle and flows to the unwelded base metal. Often the result of the puddle is allowed to become too large to correct the problem. You should keep the arc at the leading edge of the puddle. Also reduce the size of the puddle, increase the travel speed, reducing wire feed speed being asked with the Schlight whipped in motion. Lack penetration, lack of penetration result of the too little heat input weld zone. The heat input zone is too low. Increase the wire feed speed to get higher amperage. Also may travel with reduced wire stick out. Burn through too much penetration is called having too much heat into the welded zone. You can correct the problem, reduce the wire speed, which turns the lower welding amperage. Also, you can reduce the travel speed. Burning through that can result having excessive amount of the root opening current. Over the problem, you can increase the wire stick out. You can isolate the torch slightly. Our whiskers are a short piece of electrode wire sticking out through the root side of welding joint. This is caused by pushing the wire past the leading edge of the welded pool. Pushing the wire past the leading edge of the welding pool. Remember the problem, you should cut off the ball on the end of the wire with the side cutters before pulling the trigger. Also reduce the travel speed with necessary with the whip in motion. Gas metal arc welding, common metals. You may use the welding equipment technique with the gas metal arc welding joint. All types of metals, however, they discover the gas tungsten arc welding process. Each of the metals requires unique welding methods. In this case, this section we discuss some of the weld methods associated with a few or more common welded metals. Carbon steel, majority of welding all metals done with the carbon steel, which may be the MIG or the weld. Carbon steel is both spray arc, short arc methods, may be the applied spray arc welding mixture of 5% oxygen and argon recommended mentioned earlier. Mixture to provide more stable arc. Also, you may mixture argon, carbon dioxide, straight carbon dioxide, straight carbon dioxide, often with high speed production welding. Having carbon dioxide arc that has no true spray arc. For the short arc, 25% carbon dioxide, 75% argon per mixture is preferred. MIG welding is a thin material of 35 thousandths inch to 1/8 of an inch edge. No edge preparation needed. A root opening of 1/16 of an inch less is recommended. For production, adequate welds of thicker material. Some of the beveling is normally required when welding planes 1/4 inch of length or greater in thickness. Should prepare a single or double V groove shown 50-60 and will include angles. Alright, aluminum joint design. Aluminum similar to that is steel alive with aluminum requires nearer joint spacing, lower welding current setting. Short arc welding methods normally use the out of position welding when welding materials between, because the short arc produces the cooler arc than spray type arc. The welding thinner material up to 1 inch in the thickness, you should use the pure argon. Spray arc welding method recommended with welder thickness. When spray arc, more heat is produced to melt the wire and base metal, which when are welding thicker material between 1 and 2 inches. Mixture 90% argon, 10% helium is recommended. Helium provides more heat input. Argon provides good cleaning action. Stainless steel, direct current, reverse polarity of 1 to 2% oxygen. Argon recommended more. Stainless steel welding, general welding, stainless steel with spray arc welding method, push technique. Welding stainless steel up to 1/16 of an inch thickness. You should use the copper backup strip. For welding thin materials, overhead and vertical position, the short arc method produces better results. And then it goes in the appendix 1 and the index, and this completes non-resident training course, November 1996, Steelworker, Volume 1, Navy, NAVED, Navy Education Trade 14250. Distribution approved for public release, distribution unlimited.